In this video, I'm going to start talking about static electricity and about where charges come from. So, and later we'll talk about current electricity, when electricity moves and we harness it for power. But now we just really need to understand where electrical charge comes from. So, electrical charge arises from the transfer of electrons from one place to another. Okay? And in chemistry, we learn about atoms, right? And atoms have three different subatomic particles. Excuse me. They have neutrons, which are neutral, they have no charge. Protons, which are positive, and then electrons, which are negative. Okay? And neutrons and protons, they're in the nucleus, right? So they're kind of wrapped up in the atom. Whereas the electrons are outside in clouds, in the exterior of the atom, so they more easily move from one place to another, or transferred from one place to another. Okay? So remember, when you gain electrons, or electrons go from one thing and it's gained by another, you actually become negative, right? Because you have gained more negative charge. If you lose electrons, you actually become positive, which kind of seems backwards, right? Because if you're losing something and you become positive, you're gaining something, you become negative. But remember, you're losing or gaining a negative charge. Okay? So this brings us to the idea of conservation of charge. Conservation of charge is really just like every other conservation law that we have learned, right? That when charge is transferred from one place to another, the amount that leaves one object is equivalent to that which is gained by another. So the amount of negative charge lost by one object is equivalent to that gained by another. Okay, which really makes sense. Like if we look and you have like an object here, and we'll just say that it's got like 10 positive charges and it's got 10 negative charges. And you have another object over here that's the same, that has 10 positive charges and 10 negative charges. If I were to allow 2 electrons to jump over here, right? Now we have a scenario where we have 10 positive and 8 negative. And then over here, you've got 12 negative and 10 positive. So this thing has a net charge of -2, and this thing has a net charge of +2. So the amount of negative charge lost by this is equivalent to that gained by the other. Okay? Now, also remember that if we look here, the amount of negative charge lost by this is also equivalent to its positive charge. Okay? Now, in chemistry, we really just deal with, protons being +1, electrons being -1. But when we get to physics and we start to learn about electricity, charge actually has a unit, and the unit for a charge is coulomb. Okay? So the unit for charge, okay, which is written with the variable Q, okay, is a coulomb. Okay? Each electron is equivalent to 1.6 times 10 to the -19th coulombs. Okay? We could also say that so if I took the inverse of that, 6.2 times 10 to the 18th electrons is equal to 1 coulomb. Okay? So remember, like, we're talking about a huge number of electrons equals 1 coulomb of charge. When we talk about charge moving, we're dealing with a lot of electrons, and that's why we have this unit that's just a more reasonable number to deal with coulombs. Okay? So let's talk about how we actually give objects a charge. Okay? So a conductor is something that can gain charge easily. Okay? So we can actually give something a charge by doing something called sloughing or rubbing. And this is like what happens when you walk across the carpet and you like rub your feet across the carpet and then you touch the light switch and you shock yourself, right? So when you rub two objects together, and electrons move from one object to the other, and electrons move. Okay, it's like rubbing a balloon on your hair and your hair kind of stands up, or it's the static electricity you get in your clothes when you put them in the dryer. Okay. We can also charge by induction. So we can charge okay? So this here is actually, there's some contact between the two objects. Now, induction is a no contact. Okay, so let me kind of give you an example. Okay, and as we go through, you realize there's going to be like a lot of these sort of weird examples. Okay, so let's say I have a conducting sphere. A conducting sphere is essentially like a metal ball, right? And it can have charge on it, okay? And so that metal ball is made up of a bunch of atoms that have protons and electrons, and because it's a metal, the electrons can flow freely through it. Okay, so let's say I have a rod that's charged. Maybe I charged it from rubbing. Who knows, right? And let's say it's just got a lot of excess electrons hanging out on it. If I bring it close to this conducting sphere, remember opposites attract and like repel. So what ends up happening is I'll have a whole bunch of positive charge over here attracted, but the electrons will be forced over here. Okay? This is the no touching induction part. Okay? Then we sort of have another part where then if we were to attach that conducting sphere to a grounding wire, so this is called a ground. Okay? Essentially, it's attached to the ground, that's why it's called it. And the electrons are going to move from the conducting sphere to the Earth. So the electrons will leave, and they will go from the conducting sphere to the Earth. So essentially what you have left then is you have a positively charged sphere because some of those electrons have left. And that is charging by induction. So we have sloughing and rubbing, we have charging by induction. Okay? Let's go ahead and look at one more instance where we have a polarization. Okay? So this isn't a true charge, but it's when we have a polarization. Okay? So if I were to have a object, right, and it has some charge, right? So let's say I bring this big positive sphere, okay, close to something, some sort of rod here. Could be an insulator, okay, where electron doesn't flow freely. It's still going to attract the electrons to one side and push the protons sort of to the other side. And so we create this like polarized object that has a positive and a negative end just by bringing two objects close to one another. Okay? Now, I kind of want to use the idea of this rubbing really quick to just give you an example of a type of problem you'll see in a homework, okay, where we deal with like net charge, okay, or charging by contact, right? So let's say I have a balloon, okay, and I go ahead and, here I am, and I rub that balloon on my hair. So what ends up happening is a bunch of electrons jump from my hair to the balloon. Okay? So let's say 5 electrons have jumped over here. Actually, let's say 1, 2, we'll just say 5 because that's the math I've already calculated. So 5 electrons have jumped from here to here. I want to know how much charge that is. So how much charge? Okay, remember Q. Okay? And so I would say, okay, well, I have 5 electrons that have jumped, and I know every electron is 1.6 times 10 to the negative 19th coulombs. So I would just multiply this number, and an electron is negative, so we would say that I'd have it up with a negative 8 times 10 to the negative 19th coulombs of charge on the balloon. Okay? Now, we could also say how much charge is in my hair, and then the answer would be, well, a positive 8 times 10 to the negative 19th. Okay? So hopefully from this you have a little bit of an idea of movement of charge from one place to another. Okay? One quick other thing that I want to show before I cut the video off. This just shows an example of both rubbing, right? So if I take this balloon over here and I rub it on this wool sweater, it picks up electrons. Okay, and then it also shows an example of polarization. So if I push this over close to some sort of insulator, you can see that the electrons would then be repelled, and I could polarize this object here. Okay, in the next video we'll start to talk about electrical force.